Good afternoon to all. Welcome back to my channel. Hi, this is Manoj Rao. Today I'm going to solve the introduction to machine learning of assignment 6, week 6 questions of NPTEL SWAYAM. So these are my credentials and now we're going to solve these questions. Let's start. You can see guys, this is the question and you can see there in assignment 6 week 6 introduction to machine learning you will find 8 questions, okay, and we try to attempt the 8 questions. Let's start the first questions. Yeah, see, uh statements. Decision tree is an unsupervised learning algorithm, okay. The reason is the splitting citations use only the features of data to calculate their respective measures. So, if you see, the statement is also a false statement and the region is also a false regions. You can see the answer here. The statement, you can see the correct answer is the statement is a false statement. The statement is a false statement and the region is false. Okay, we can see the explanation here why this statement is a false statement, because the statement one decision tree here, the decision tree is a supervised learning. Okay, it is not a unsupervised learning. So decision tree as a are the supervised learning algorithm, not unsupervised. So they require labeled data to learn the relationship between the features and the target variables. Okay, reason is the splitting criteria of decision trees, that is gain impurity, entropy, uses both the features and the target variables to calculate the best split. The reason is incorrect. Because why it is incorrect? Because it claims that only features are used, which is not true. Okay, only features are used, which is not true. So especially this is a supervised learning algorithm. So here mentioned is non-supervised. That's why this statement is what? The statement is false and the reason also is false. Question number 1, option D is the right answer. Moving to the question number 2. Increasing the Turing strength in a decision tree by reducing the maximum depth. You see, 5 options are there. How many options are there? 5 options are there. Out of 5 options, you can choose the might lead to underfitting if set too aggressively. Might lead to underfitting if set too aggressively. To option C, you can see here. Yeah, yeah, might lead to underfitting if set too aggressively. Okay, here the correct answer is that. And you can see the explanation part here. Pruning reduces the complexity of the decision tree by limiting the depth, removing branches. Okay, if the pruning is too aggressive, the tree may become so simple and fail to capture the important patterns of the data, leading to underfitting. So it doesn't always improve the validation accuracy, nor does it eliminate the need for the validation data. So it might lead to underfitting if set is too aggressively. Okay, of two, option C would be the right answer. Moving to the question number 3. What is the common indicator of overfitting in a decision tree? What is the common indicator? The common indicator is the training accuracy is high while the validation accuracy is low. Okay, it is overfitting means the training accuracy is high while the validation accuracy is low. You can see question number 3. Okay, question number 3. The training accuracy is high. While the validation accuracy is low. This one, option A is the right answer. Okay. The training accuracy is high while the validation accuracy is low. We can also explain here why. The overfitting occurs when a model performs well on the training data but poorly on sync data, that is validation or test data. Decision tree is too deep or complex may be achieve high training accuracy but fail to generalize, resulting in low validation accuracy. That's why we choose the training accuracy is high while the validation accuracy is low, which is option 3, option of question number 3, option A. Okay, then moving to the question number 4, you can see, guys, consider the following statement. Statement 1 is decision tree are linear and non-parametric models. Question number 2, a decision tree may be used to explain the complex functions learned by the neural networks. Okay, so you can choose here the in question number 4, the statement 1 is false. Okay, the statement 1 is false, but statement 2 is true. That means this statement is true, but first one is false. Okay, for option C, which choose here, because you can see Yeah, the statement 1 is false, statement 1 is false, but statement 2 is true. This one. 4 option C. Why statement 1 is false, but statement 2 is true? Statement 1 is false because the decision tree are non-linear models, not linear. Okay, it is mentioned that it is a linear. It is mentioned that it is the decision tree are non-linear models, non-linear model. Okay. They make decision based on hierarchical splits while are inherently nonlinear. So in statement 2 is true because decision tree can be used to interpret or explain the complex decision boundaries learned by the neural networks, especially in a technique that is tree regularizations or rule extractions. That way, we can choose here the statement 1 is false, but statement 2 is true. Okay, 4 option, you can choose C. Moving to the question number 4 option C. Moving to the question number 5. Entropy for a 50-50 split between two classes. Two classes, it will be how much? It will be 1. Okay. You can see it is explanation part. You can see a 50-50 split between two classes are options are given. Out of we choose this option 0. Or sorry 1. Option 1. Because entropy measures the impurity or uncertainty in a database. For a 50-50 half-half split between two classes, the entropy is maximum, which is calculated as entropy equal to minus 0.5 log 2, 0.52 plus 0.5 log 2, 0.5, that will be 0.5, 0.5 equal to 1. This represents the highest level of uncertainty. Highest level of uncertainty, that's why we choose 1. Clear? So 5 option C would be the right answer. Moving to the question number 6, consider a data set. Consider a data set with only one attributes categorical. Suppose there are 10 unordered values in the attribute. Then how many possible combinations are needed to find out the best split points for a building the decision tree classifier? How many? See, we can choose here 511. 511. How it is being calculated, I am going to show you. Okay, see. The question is this one. Answer is with 511. How is this 511? We can explain one by one. For a categorical attribute with n unordered values, the number of a possible binary is 2 to the power n, 2 to the power n minus 1, again minus 1. Here n equal to 10, that is equal to 2 to the power 10 minus 1 minus 1. Here 2 to the power 10 minus 1, that is 2 to the power 9 minus 1. You can see 2 to the power 9 equal to 512 minus 1 equal to 511. Okay, so this is the answer. This is because each split divided the categorical in two subsets. Each split divided the categorical into two values. You know the calculation how it is calculated. So remember this formula 2 to the power n minus 1 minus 1. Okay, so after that we get the result 511. Okay. Next guys, next question number 7. Then what is asking about question number 7? Question number 7 is asking about consider the following data set. Okay, age, vaccinations, tumor size, tumor site, and Mulginand. Okay, then what is the initial entropy of the Mulginand? Okay, what is the initial entropy of the Mulginand? So you have to calculate what is the initial entropy of Mulginand. Then what would be the answer? We have to find the answer here first. Then we will choose. C. Answer would be 0.978. 0.978. That is option B. Option B. 0.9798. 9798. Then let's see how it is 9798. The explanation is here. The initial input entropy is calculated based on the distribution of the target variable, that is Mulginand, for the data set. So total sample is how much? Total sample is how much? Equal to 12. Total sample is equal to 12. So Mulginand equal to 1, 5 sample, Mulginand equal to 0, 7 samples. Okay. So if 5 samples, 7 and 12 samples, entropy calculated as minus 5 by 12 log 2, 5 by 12 plus 7 by 12 log 2, 7 by 2. Then if you calculate, it is approximately about 0.9798. Okay. So entropy is calculated at 0.9798. So here 0.9798. So this is the formula of the entropy. You have to remember this formula. Okay, you have to remember this formula. So the final result will be this one. Okay, so correct answer will be 5. Question number 7, option B, 9798. Got it? 9798. What is 9798? 9798. 7, option B. Then moving to the last question. For the same data set, that means this data set, what is the info given on vaccinations? What is for the same data set, what is the info gain of the vaccinations? So for substantiation, you have to calculate the same database. What is the then if you calculate, 4 options are given, the correct option will be 0.1134. 0.1134, that means C. Option C. You can see 0.1134, this one. Okay, this one. 8, option C. Let's see the calculation part, how it is being calculated. Then information gain is calculated as info gain equal to initial entropy minus weighted average entropy after split. Okay, this is the formula you will try to remember. Initial entropy minus weighted average entropy after split. Then initial entropy is 0.9798 from question number 7. After splitting on vaccination, vaccinations, the vaccination equal to 1:6 sample, that is equal to 0.5, and malignant equal to 1:1. Vaccination if 0:6 sample, malignant equal to 0.2, 0:2, that is 1:4. So entropy for vaccinations is 1. So entropy equal to minus 5/6 log 2, 5/6 plus 1/6 log 2, that approximately this much, approximately 0.6500. Here entropy vaccination 0, it will be approximately 0.9183. Then weighted average entropy equal to how much? 6/12 into 0.6500 plus 6/12 into this one, 0.9183. So if you calculate, we will get 0.7841. So information given, information house gain. So simply the first one is 0.9798 minus this one, that's equal to 0.7841. So it is about 0.1957. 0.1957. What is closest point is, if you 0.1957, 0.1957, that is closest equal to 0.1134. Okay, 1134. That's why we choose option 8, option D. Okay, now we are going to submit our answer. Okay, going to submit our answer. The answer has successfully submitted. Once again, we will try to verify our answer. Question number 1, D. Question number 2, it is C. Question number 3, option A. Question number 4, option C. Question number 5, also option C. Question number 6, option B. Question number 7, option B. And question number 8, option C. Okay, guys, we successfully, you can also take a screenshot of this calculation part. I'm going to let you know once again. Okay. Yeah, this one, question number 8, calculation part, you have to take a screenshot of this, and you have to just take a screenshot of this. Is how the information gain will be calculated. Okay, so if you like this video, you can share, you can subscribe my channel, and you can wait for my next video. Till then, if you have any questions, any queries, you can put your queries or question in my YouTube comment box. You are mostly welcome. Okay, I'll try my best to give the answer of your questions. Okay, all the best for your exam. If you are going to prepare, take care of yourself. Goodbye.